Okay, in this video we're going to take a quick look at a concept called pressure. So to kick us off, basically what is pressure? Sorry, just jump back there. So pressure is essentially when a force is applied over an area. So when we apply a force, if I were to give you a push or a shove, I could push with my entire hand, like my flat hand, or I could push you with one finger. Now the size of the force might be the same, but the pressure that's applied would be different because it's applied over either a larger area or a smaller area. So the formula for pressure, and this is the formula that will be given to you in your exam, is pressure, use a capital P, equals force divided by area. So again, this can be rearranged. So we'll look at that. It can be rearranged. It can be put into a triangle and rearranged as follows. So pressure equals force of area, or we can rearrange that obviously. Force equals pressure times area, or the area is force divided by pressure. But let's just stick with pressure for a moment. So pressure equals force divided by area, and talk about quickly what does that actually mean. So pressure, the pressure that's applied is the force divided by the area. Sorry, my line went a bit crazy there. Alright, great. So what this is saying, now again, you need to be able to, and I'll show you a good example of this in a second, you need to be able to explain what this formula is showing. So essentially it's saying, if I push with more force, I'm applying a greater pressure. If I push with a larger area, if I apply the force to a larger area, I'm pushing with less pressure. So think of it like this. If I'm pushing you with my flat hand, alright, if the force is the same, with a flat hand, that might be a larger area than, say, if I push you with a needle. If I poke you with a needle, and I apply the same force, well, it's going to apply a whole lot more pressure because we're applying it to a smaller area here. So essentially, when we apply a force, the size of the force is proportionate to the pressure. So doubling the force would give us twice the pressure. But the area, if we make the area larger, we're actually applying less pressure. And think about this, a good example is if I stand on your toes, and I'm wearing regular old shoes, well, that's going to apply a decent amount of pressure already. What would happen if I stood on your toes and I was wearing high heels? Well, if I'm wearing high heels, that's going to hurt a whole lot more. You can imagine someone stepping on you with their stilettos. It's going to hurt a whole lot more because although the same force might be applied, there's a much smaller pressure. A much smaller area over which it's applied. That heel is a lot smaller, so we're applying the same amount of force to a smaller area means we're applying more pressure, and that's why it actually hurts more. So if someone stood on your toes with just flat shoes versus high heels, the force they're applying is the same, but because they're applying it to a smaller area, it means they're actually applying a greater amount of pressure, and that's why it's so much more painful. Alright, so let's have a look at an actual example of this, and this is actually a pretty tricky one. This always stumped a few students. So we've got a question here, and I'll just zoom out a little bit there. While on a sandy beach, the woman sees a car, mass 1100 kg, 1100 kg, that is stuck in the sand. The photos below show the tread patterns of the tractor's rear tires and the car's rear tire. Now this is obviously part of a larger question, and so it's sort of taken a little bit out of context, but it's fine, we should still be able to do it. So we've got the tractor tread here and the car tread. Now compare the different treads and of the tractor tire and car tires in terms of force, surface area and pressure applied. Use this comparison to explain why the car gets stuck in the sand but the tractor does not. Well, let's firstly have a look. If I I can find my mouse. There we go. Let's have a look at, so it says here, in terms of force, surface area, and pressure applied. So firstly, let's talk about force. How would the force compare between a tractor and a car? What do we think? Well, the force, what kind of force would be acting on a tractor or a car? Well, we're talking really here about the weight force. So that, remember, is its mass times gravity, the weight force. So the weight force of a tractor is probably going to be larger, probably going to have a bigger force. Oh, my A got a bit funny there. It's probably going to be larger, so we'll put large there and maybe small here. It's going to be much larger than a car, probably just because a tractor is going to be bigger and heavier than a car would be. So we've got a larger weight force on our tractor. Well, what about surface area? Well, let's have a quick look at our tyres here. So the surface area of the tyre, if you were driving on the road with this tyre, it's because these bits stick out so far, it's only these yellow, the bits that I'm colouring in yellow here, I'm sort of highlighting for you, it's only these bits here that would actually be in contact with the road. So you can see here, this is actually the surface that makes contact, at least initially. This is the surface that makes contact with the road. Now if you look at our car tyre here, you can see although there are small gaps, and I'm not going to be able to colour all of this in for you, but although there's sort of small gaps here, most of the tyre is actually in contact with the surface, with the road. So you can see here all of this is, so apart from the small grooves, most of it is actually in contact with the road. Now I'll only do half of the tyre, the other half I could colour all that in too. But you can see here which one actually is a larger surface that's in contact with the road. Well, it's actually the car tyre. So here we've got the area, or the contact area, is going to be larger. And on this side, our tractor is going to have an area, a contact area, that is smaller. So it's got to do with the size of that tread, or the shape of that tread. There's less surface, contact surface, that actually contacts the surface of the road. So what does this mean in terms of the pressure applied, which is what they asked here? Well, if pressure equals force divided by area, what they essentially wanted you to do here, now you don't have to do any kind of calculation, but what you would say is if you've got a larger force, you would get a larger pressure. And having a smaller area over which that's applied gives you an even larger pressure. So a combination of a large force over a smaller area means you get greater pressure applied. So there's going to be much more pressure applied by these tyres than by the car tyres. So how can we use this to explain why the car tyre gets stuck but the tractor tyre doesn't? Well, basically, if you've got more pressure applied, the tread of the tyre is going to sink into the sand further, and that's going to give it more grip. So think about it like shoes. If you're wearing high heels, or maybe you're wearing like rugby boots with cleats with studs in them, because the pressure is applied over a smaller area, they're going to sink into the ground, and they're going to give you more grip in the ground. The tread here has so much area, it's not really going to sink into the sand much, and so it's not going to have the same grip. So what they were looking here for, guys, was recognizing that the tractor is probably heavier, so the weight force is larger. The area, the contact area, is actually smaller, right? Which means there's less surface area kind of in contact with the road, and that the pressure, well, pressure is equal to force divided by area. So a larger force and a smaller area, both of those things are going to give you a much larger pressure, and the pressure is going to cause that tread to sink into the sand, and that's going to give you more grip or traction. So hopefully that makes some sense. We've got a similar example, which is actually my rugby boots example essentially, and we'll have a look at that one. Just move down to that. Okay. So here we go. We've got an example with some rugby boots. So a student with a mass of 40 kg uses the football boots shown above. One boot without studs has a surface area of 165 centimeters squared. Now they've been nice enough to give us that in meters squared. So area is always measured in meters squared, is in contact with the ground. One boot with 6 studs in it has a surface area of only 6 centimeters squared. So you can imagine that it's a lot less. Here most of the surface on the bottom here would be touching the ground. Here it's only the very tips of these points that would be touching the ground. So calculate the pressure exerted if the student stands on 1 foot on a hard surface. Now this is really key here, that it actually tells us 1 foot. Otherwise we'd have to double or factor in the fact that you'd normally be standing on 2 feet. On a hard surface for the boot with and without studs. So give an appropriate unit with your answers. So again, we can use our triangle here, which was pressure. Well, I know my formula. The formula that's given to me is pressure equals force divided by area. So we can already use that. Now, if you had to put that into a triangle, remember, well, we've got forces on top here, so force is going to go on the top of the triangle. So we can, if we wanted the triangle, we could go like that. And obviously you can rearrange triangle. We can see their pressure is force over area anyway. So, without studs, so we should write in our formula, pressure equals force divided by area. So the pressure equals, now the force, well, what's the force here? What's the force pushing him down? Well, so we need to work out the force here first. So what's that force that normally pushes us down into the ground? Right, it's the weight force. So his weight force is going to be equal to his mass times gravity, which would be given to us on the front cover too. So it says here his mass is 40 kg. So we'll go 40 times 10. So his weight force is 400 newtons. Okay, so we've got the force is 400. There we go, 400 newtons. And we divide that by what's the area here. So we've got the area. Now we're going to start off with the shoe without studs. So that's the one here. Divide by 0.0165 by 0.165. Now you can plug that into a calculator obviously, so you're definitely allowed to use a calculator, and that is equal to 24242. It's an interesting number, so 24,242. And that is, we can use 2 different units here actually. Pressure is something that can be expressed in 2 different units. Now because it's force divided by area, we can go, the unit for force was newtons divided by area is in meters squared. Now because it's newtons divided by newtons, it's newtons per square meter, we do a little -2, rather than normally meters squared is just the m with the little 2. So here it's newtons per meter squared, it's newton, a capital N, a little m, and a -2. Or we can use the unit, pascals is the unit for pressure. So remember P. Now you could use either of these, would be accepted. They're totally correct. You could give either of those, would be accepted as a correct answer. So the answer they're looking for here is the 24,242 newtons per meter squared, or pascals. So you could use either of those units. So yeah, either of those are fine. So let's do the calculation for with studs. With his studs. So again, just scroll up there. Okay, with his studs. So this time we're taking the pressure. So I'll do our formula. Pressure equals force divided by area. Okay, so the force again, it's that weight force was 400 divided by 0.0006. Okay, and the answer we get out is, once again, it's a bit of a crazy number, 6666667, and that is in, again, newtons per meter squared, so that little -2, or pascals is the other unit we could have used. And you can use either of those, you'll be marked correct, so whatever you find easier to remember. Alright, fantastic. So things to watch out for there. The weight force, the weight force, you can't just use the kg there. Remember, you got to the force due to gravity, or the weight force, is the mass times gravity, times 10. So you would have lost a mark for if you'd used 40 there. And the other thing, it's just that using that formula and remembering the unit. So newtons per meter squared, or pascals. So we can see here, compared with our last answer, so our last answer up here, sorry I rubbed it out, was 2,242. So we can see down here we've got a much bigger number, that's 24,000, this is 666,000 whatever, so much bigger number. With the studs, you're applying much greater pressure, you're applying a lot more pressure, and we'll talk about the effects is actually just in the next question down below. Alright, let's have a look. So, discuss the advantage gained by the student when running on soft grass, on a soft grass football field, while wearing the boots with studs compared to wearing boots of the same size without studs. You should compare the pressure exerted on the ground by boots with studs and the boots without. Explain the relationship between surface area and pressure exerted. Explain how the difference in pressure would help the student run on a softer surface like grass. So essentially here, guys, compare the pressure exerted. So with studs is going to give you a much greater pressure. We just worked that out. So the boots with studs apply much greater pressure. So there you go, easy, there's your comparison. Explain the relationship between surface area and pressure exerted. So this is, again, it's basically just getting you to explain this formula. The pressure exerted is equal to the force divided by area. So what we're saying here is the force here stays the same. It's only the area, the contact area, that's changing. So the studs have less contact area, which actually means it's going to give us a larger pressure. So if we make the A here a smaller number, the area, because it's divided by, if the A here is a smaller number, we get a larger pressure. And that's what they want you to explain here. By increasing, by having a smaller contact area, we're actually applying a larger pressure. Now if you're not sure you've got it right, just plug in some imaginary numbers. Call the F here, 100. And have a look at, if we had the area, if the area was 1, or let's make it 10, if the area was 10, then my pressure would be 10. Well, what happens if I make the area smaller? What happens if I make it the area 1? Oh, well, now suddenly my pressure is 100. So by making the area smaller, I've made my pressure bigger. Alright, lastly, explain how the difference in pressures would help the student run on a softer surface. So basically, again, here it's like with our tractor. Because there's greater pressure on the foot with the studs are more likely to sink into the ground, and that'll give him better grip when he's running. So a larger pressure means that the studs will sink into the ground, be pushed into the ground, and that will give him a much greater grip on the ground. Now, one thing just to be aware of, they love to ask questions like this, or sometimes in a test you'll get a question like this, where it talks about, it'll give you an example with using feet like this, like high heels or rugby boots. And the one thing that you may have to remember is, is that normally a person stands on 2 feet. So here they were kind enough to say work out the pressure on 1 foot. But if they hadn't, we would have had to do our calculations slightly differently. Now the pressure is still always equal to the force divided by the area. And we worked out, say, for this first one, that is 400 divided by... Now if we were working out the pressure when you're standing on 2 feet, what number would we have to use for the area? Well, we'd take this number here, but we'd have to double it. So we'd have to go 0.165 times 2. We'd have to double that, and really we should double that before we type anything else into the calculator. So we really we'll be dividing then by 0.0, what is it, 3, I think, is that right? 0.6 to those 3, yep, 0.033. So we're just doubling the area. Now the reason I mention that is a lot of students, what they'll do, they go, oh yeah, you're standing on 2 feet, so I've got to double, and they'll double their answer. They'll basically double the pressure. Well, hold on, if we're standing on 2 feet, and this is really, shows a key understanding of whether you really get the idea. If we're standing on 2 feet, that would double the area. Well, what effect is that going to actually have on the pressure? Well, if we double the area, if we double this value, we're actually getting half the pressure. Okay, so just be careful in that. If you've got an example where sometimes they use tractor wheels or feet, shoes, ice skates, all those sorts of things come up. If you need to double it because you're standing on 2 feet, remember it's the area you're doubling, not actually the pressure. Okay, it's a common mistake. Alright, one last little thing to look at, and this is a little bit of a mean or a tricky kind of example. Would be here, and I'm sorry this is really unclear, it's not the clearest of diagrams, but this basically explains how a hydraulic system, sometimes it's used like brakes and cars are driven by these, how they work. So what you've got here is essentially imagine like a syringe. It's got a plunger in it, and when you put your foot on the brake, it compresses a fluid. That plunger pushes against the fluid and compresses it, creating pressure inside the hose or the tube. Now on the other end, there's a plunger that gets pushed out, and that applies a force against the brake pads that squeeze onto the disc behind your wheel and slows the wheel down. Now all you've got to realize, if you've got a hydraulic system set up like this, so basically like a plunger on one side where a force is applied and it creates pressure in a hose that's full of fluid, and that pushes the plunger on the other end out, all you've got to realize here is that the pressure you put in is going to be the same as the pressure you get out. Because if you think about it, the fluid inside the hose is going to have the same pressure all throughout it. What that simply means is that if you put a force in over a certain area, so the pressure is the force divided by area, you'll get a proportion. You'll get the same amount of pressure out on the other end. Now you can do a few tricky things like that, because if we make this a really small plunger, so the area is really small, it means that we put in a small area here, might give us a big pressure. Well, on the other side, if we use a large plunger, to get the same amount of pressure, we're going to get a much larger force out. So that's one way you can kind of, multiply or increase the force output by changing the size of the area. So it's just recognizing here that the pressure that's put in is going to equal the pressure you get out, which actually means the force divided by the area in is equal to the force divided by the area out. And so if you get a question like this, you know, really what you'd have to do is they might say, you know, let's say you apply a force of 10 newtons to an area of, you know, let's say 10 square, let's say a meter squared. It's a ridiculous number, but it's just going to make our calculations easier. And let's say on the other end, we're applying that force to an area of 10 meters squared. And they might ask us, what is the force that's going to come out on this end? Well, it may sound really tricky because, you know, we've got a force here and an area here and another. Well, basically you work out the pressure on this side. So pressure, it's not R. Pressure equals force over distance, force over area. So in this case, that's 10 divided by 1. So that's going to be, we would have 1 pascals. 1 pascal. So over on this side, now that we've got the pressure, we can go, well, force. So let's do our triangle. Alright, so it was, you know, force goes in the top because it was on the top of the formula. Just put it over there. And the bottom two, it doesn't actually matter which way around they go. Alright, so if we've got force is actually equal to pressure times area. Oh, sorry, made a mistake there. Force is actually equal to pressure times area. So in this case, the force is equal to, we've got 10, we worked out the pressure over there. Sorry, our pressure was 10, so that was 10 pascals, 10 divided by 1 is 10, times an area of 10, so over here our force is 100 newtons. Okay, so I hope that kind of made sense. Sorry, I made a mistake there. So on this side, if our force was 10 newtons and our area is 1, so force divided by area, 10 divided by 1 is 10 pascals. And that pressure is going to be transmitted through the hose. And on this side, if the plunger is a whole lot bigger, it's 10 meters squared, it's a pretty giant plunger, then our force, well, we can use the pressure that we've already calculated, is pressure times area, 10 times 10 is 100 newtons. Okay, so the key thing to realize here is essentially just that the pressure, if you've got this hydraulic system, the pressure on this side is equal to the pressure on this side. So you might be asked to work out the pressure on one side and then use that on this side to work out the force that comes out on this end. Okay, that last one's really tricky, and it's probably unlikely we'll get something quite that hard, an example like that with the hydraulics, but it is definitely possible, so it pays to be prepared. Anyway, I hope you found it helpful.